Okay, guys, here is the back of your 6.3 day 3 notes. So continuing on with these even and odd identities of your trigonometric functions, look at example D. They asked you for the tangent of negative 37 pi over 4. Well, remember, you have just seen that the tangent of negative theta is equal to negative tangent theta. So I can rewrite this as tangent negative 37 pi over 4. It's going to equal negative whatever the tangent, or I should say the opposite, or whatever the tangent of positive 37 pi's over 4. All right, so we have to figure out, well, what is the tangent of 37 pi's over 4? Well, let's figure this out, right? Where does 37 pi's over 4 land? Well, if we're dealing with pi's over 4, right? Halfway around a circle is pi radians, all the way around is 2 pi. So in the worlds of pi over 4, it takes 4 pi's over 4 to get halfway around, and it's going to take 8 pi's over 4 to get all the way around. So I'm trying to hit 37 pi's over 4. So where do they land? Well, let's figure this out. Halfway around is 4. All the way around is 8 pi's over 4. So there's 8 pi's over 4. I got a lot more to go. So if I go halfway around again, that's 12 pi's over 4. If I go all the way around then, that's 4 more. That is going to be 16 pi's over 4. If I go halfway around, that's going to be 20 pi's over 4. If I go halfway around again, that gets me another complete rotation. That's going to be 20. Now 4 more. That's 24 pi's over 4. Halfway around gets me to 28. Another halfway gets me all the way around again, and that's going to be 32 pi's over 4. So now if I go another half, that is 36 pi's over 4. 36 pi's over 4 land right there, which means my 37th is going to be in this quadrant. So that is 37 pi's over 4. So when you take the tangent of 37 pi's over 4, that's the same thing as taking the tangent of a pi over 4 who landed in quadrant 3. Well, what is the tangent of 45? What is the tangent of a 45-degree angle? That's 1. Use your right triangles or your unit circle. That is 1. The tangent of a 45-degree angle is 1. And if you landed in quadrant 3, all students take. The tangent of any angle who lands in quadrant 3 is a positive ratio. So that's positive 1. So that means if I go back here, that's going to be the opposite of what is the tangent of 37 pi's over 4? It's 1. So that means your answer is the opposite of that. It's negative 1 is the answer to that question. Okay? All right, what about this one? What is the cotangent of negative 3 pi's over 2? Well, based off what we just learned, cotangent is odd. The cotangent of negative theta is equal to negative cotangent theta. So that'll be equal to negative cotangent 3 pi over 2. Well, where do 3 90-degree angles land you? That's 1, 2, 3. That is 3 pi over 2. So your answer is going to be the opposite of whatever his ratio is. Well, what is the ratio, the cotangent ratio at 3 pi over 2? Well, tangent would have been y over x, so cotangent is x over y. So technically that is the opposite of 0 over negative 1, which would be the opposite of 0, but there's no such thing, so it's just 0 is your answer to that question. Okay. All right. Well, if I asked you what is the cosine at negative pi? Well, again, you've probably answered that before. Go see where negative pi lands and get his x coordinate. Or now that you know the identity, we just learned that the cosine of negative pi is equal, the cosine of negative theta is equal to cosine theta. So I can rewrite that as cosine negative pi is equal to the cosine of pi, because he's an even function. So when the opposite of x goes in, the same y still comes out. So now cosine pi would be, well, where do pi radians land? Right there. What is that ordered pair? It's to the left 1. The cosine would be his x coordinate, so the answer is negative 1. And again, even if you did the problem the way it originally was stated, cosine negative pi goes this way. He still lands in the same spot as pi. So they're going to have the same cosine ratio. They're going to have that -1 cosine ratio. Okay, now we're going to use all those identities to rewrite trigonometric functions so that we can cancel stuff out and get a simplified answer. Okay, so let's see this one. What if you were asked to use the properties of trigonometric functions identities to find the exact value of each expression? So you should not need a calculator to find these out. All right, so what if they asked you to take the sine of 80 degrees and times it by the cosecant of 80 degrees? Well, guys, both trig functions are using the same angle, 80 degrees. That's perfect. That means I can probably use an identity. Well, remember, sine 80 degrees times the cosecant of 80 degrees, he's the reciprocal of sine. So I can rewrite him as 1 over the sine of 80 degrees. And now what happens to a sine 80 here and a sine 80 down there? They cancel, and I'm just left with 1 is my simplified answer. Okay, look at this one. Let's see if we can find an identity to help us simplify this one. This one says that the secant squared of 18 degrees minus tangent squared of 18 degrees. Well, guys, secant squared, tangent squared, that looks like a Pythagorean identity, right? And they're both using the same angle. If this was 18 and this was 28, I could not apply an identity. But because they're using the same angle, I can. Well, guys, look back to your identities. Secant squared minus tangent squared. Secant squared theta minus tangent squared theta equals 1. So guys, this is literally secant squared theta minus tangent squared theta, except theta is 18 degrees. So what's this going to equal according to my identity? It equals 1. So I don't even have to know what the secant of an 18-degree angle is to figure out this answer. I can use an identity, a statement of equality, to interchange things in and out of a problem. All right, well, look at this one. It asks for the cotangent of 20 degrees minus the cosine of 20 divided by the sine of 20. Well, guys, cosine over sine is cotangent. I can rewrite this as cotangent 20 degrees minus the cotangent of 20 degrees. And what's cotangent 20 minus cotangent 20? It's 0. I could have even rewritten this one as cosine 20 over sine 20, and they still would have subtracted to 0, okay? All right, look at this one. This one says the cosine of a 400-degree angle times the secant of a 40-degree angle. Well, something's not right here because these are two different angles. So to apply an identity, the angle has to be the same. Well, 400 degrees, do you agree? That's bigger than 360. So he is more than one complete rotation. So I can rewrite him in terms of his reference angle. Where does 400 degrees land? Right? It's all the way around and then a little bit more. There's 400 degrees. So this was 360. So do you agree the reference angle is what? 40 degrees. So that means that 400 degrees lands in the exact same spot as 40 degrees. So that means the cosine of 400 degrees is the exact same ratio as the cosine of 40 degrees because 40 and 400 land in the same spot. They're gonna have the same cosine and sine ratio. So I can rewrite cosine 400 degrees in terms of his reference angle. Cosine 400 is the same thing as cosine 40 degrees. Times the secant of 40 degrees, that's the reciprocal of cosine. So I can rewrite him as 1 over the cosine of 40 degrees. And now what happens to a cosine on top and a cosine on bottom? They cancel. And I'm just left with 1. Okay? So sometimes you have to rewrite in terms of the reference angle to get that identity to play. All right, look at this one. The sine of negative pi over 12 times the cosecant of 25 pi's over 12. All right, well, let's figure this out. Well, the sine of negative pi over 12, we know that the sine of negative theta is equal to negative sine theta. So I can pull that negative out and rewrite that as the opposite of sine pi over 12. Okay, and then times that by, well, the cosecant of, well, where does 25 pi's over 12 land, right? So let's figure this out. Where do I want to go? Here, right? So now we got pi radians gets us halfway around, and 2 pi radians gets us all the way around. So in the world of pi's over 12, it takes 12 pi's over 12 to get halfway around, and it's going to take 24 pi's over 12 to get all the way around. So that means that one complete rotation around is 24 pi's over 12. So 25 pi's over 12 is going to land in the quadrant right after it. All right, so who's your reference angle? Between 24 pi over 12 and 25 pi over 12, 1 pi over 12. So that means 25 pi's over 12 land in the same spot as 1 pi over 12. So that means all their cosine and sine ratios are going to be the same because these are angles that land in the exact same spot. So I can rewrite this as the cosecant of what angle lands in the same spot as 25 pi over 12? 1 pi over 12. All right, and then I can say, well, this is the opposite of sine pi over 12 times, well, the cosecant of pi over 12, cosecant is the reciprocal of sine. So I can rewrite that as 1 over the sine of pi over 12. And now what happens to my pi, sine pi's over 12? They cancel, and I'm left with a negative sign times 1. So that is negative 1. Okay? All right, so it takes a little creativity to get these ones to come out and play. All right, well, look at this one. The sine of negative 20 degrees divided by the cosine of 380 degrees plus the tangent of 220 degrees. Well, guys, I have way too many angles going on. So I need to rewrite these ones that are bigger than 360 or even smaller. I need to rewrite them in terms of their reference angle, okay? Their angle between 0 and 90. All right, well, we know that the sine of negative 20 degrees, I can rewrite that as negative or the opposite of sine 20 degrees. I know that's one of my identities, all right? That's the fact that he's an odd function. Then I'm going to divide that by, well, cosine 380. Let's rewrite that in terms of his reference. So where is 380 degrees? Well, obviously it's one complete rotation because that's 360. And then I have to go a little bit more to get to 380. So guys, what's the reference angle in between 360 and 380? It's 20. That means that 20 degrees and 380 degrees land in the exact same spot. So that means the cosine of 380 is going to have the exact same ratio as the cosine of 20 degrees. So I can rewrite that as cosine 20 degrees because they land in the exact same spot. All right, and then I'm going to add that with the tangent of 200 degrees. Well, where does 200 degrees land? I need to rewrite this in terms of his reference angle. So let's see, 200 degrees, right? Well, here's 180. So 200 degrees lands right there a little bit past it. So what is the reference angle to 200 degrees? It's 20. What? So that means that taking the tangent of 20 degrees, that's the same thing as taking the tangent of a 20-degree angle who landed in quadrant 3. And what should your ratio be for an angle that lands in quadrant 3 for the tangent function? All students take. That means that the tangent of a 20-degree angle in quadrant 3 is a positive ratio. So I can rewrite this as positive tangent 20 degrees. Okay? All right, what do we got? Well, guys, sine over cosine is tangent. So I can rewrite this as negative tangent 20 degrees plus the tangent of 20 degrees. Well, what's negative tangent 20 plus tangent 20? It's 0. They cancel. The answer is 0. Okay? All right. So then they're going to start asking you stuff like this, which, again, you have to remember that the trig functions are periodic. After so many inputs, the outputs start to repeat, right? We saw 20 degrees has this cosine ratio. If I go to 380, it has the same cosine ratio, any angle that lands in the same spot, right? Well, remember, the period for sine and cosine was 2 pi. Every 2 pi radians, the output started to repeat. So any angle that is 2 pi radians away from another angle will have the same sine and cosine ratio. But the tangent function, he had a period of pi radians, right? Every pi radians, the tangent and the cotangent function start to repeat their outputs. So any angle that lands pi radians away from an angle with the tangent function will have the same ratio. All right, so look what they said. They said if the sine of angle theta is equal to 0.3, so the sine ratio for angle theta is 0.3, all right? Find the value of, well, sine theta, which we already know, it's 0.3, plus the sine of theta plus 2 pi radians, plus the sine of theta plus 4 pi radians. Well, guys, let's figure this out. The sine of theta, we already know, is 0.3. We know his ratio, plus. Well, guys, if you are angle theta, let's say that's angle theta. If I rotate 2 pi radians all the way around, theta plus 2 pi radians, he lands in the exact same spot as theta. So he's going to have the exact same ratio. So the sine of theta plus 2 pi radians lands in the same spot. He has the ratio of 0.3 also. All right, and then at angle theta plus 4 pi, well, guys, I already rotated 2 pi radians around. If I rotate another 2 pi radians around, that's going to be theta plus 4 pi radians, also lands in the exact same spot. So he'll have the same sine ratio. So that is also going to be 0.3. So 0.3 plus 0.3 plus 0.3 is 0.9. And there's your answer. Okay? All right, we'll have this one. If the tangent of angle theta is equal to 4, find the exact value of tangent theta, which we already know it's 4, plus tangent theta plus pi. Well, remember, every pi radians away from this angle, the same output comes out. And then tangent theta plus 2 pi radians. So let's figure this out. We already know that the tangent of angle theta is 4. Then we're going to add, well, again, if you picture this to be angle theta, if you rotate pi radians away, halfway around from him, that's pi radians away, you get an answer that is exactly the same. His tangent ratio is the same thing as his tangent ratio. Every pi radians, the outputs start to repeat. So tangent of theta plus pi is the same ratio, 4. Plus, if I rotate, I already went pi, if I go another pi radians, that's going to be, I rotated 1, 2, that's 2 pi radians. That's theta plus 2 pi radians. He's going to land in the same spot as the original theta. So he's going to have the same ratio, which is 4. So 4 plus 4 plus 4 is 12. Okay, so those are meant to be really easy. If they're going to add the period onto an angle, then the ratio is still going to be the same, because once you land in the same spot, you're going to get the same ratio to come out. These are periodic functions, okay? So as long as you add the period to that angle, the ratio is going to be the same. The ratio just keeps on repeating every pi radians away from that angle or every 2 pi radians away from that angle, okay? All right, well, look at this one. If f of theta is equal to sine theta, then look at this. Then f of a, that means when a goes in, the sine of angle A is equal to 1/4. That is his ratio. Find the exact value of. All right, well, guys, we already know if f of theta is equal to sine theta, then I already know by definition f of negative theta would equal negative sine theta. That's one of our odd identities, right? So if I plugged in f of negative A, the opposite of that input, then I already know the opposite of the output has to come out. So that means that f of negative A, when the opposite of A goes in, then the opposite of that output has to come out, which would be negative 1/4. Okay? All right. And then look at this one. Well, f of A, right, is going to be, obviously, what do we know f of A is? It's 1/4. Plus, well, what about f of a plus 2 pi? Guys, this is the sine function. Every 2 pi radians, you're going to land in the same spot. So every 2 pi radians, the output repeats. So if this is your angle and you add 2 pi radians to them, you've landed in the same spot and you're going to get the same output, the same ratio. All right, if you add 4 pi radians, well, that's 2 pi radians away from this angle. So now you've rotated 2 times around, but you're still landing in the same spot as where this angle landed. So the ratio will still be the same, which means you're adding up 1/4 plus 1/4 plus 1/4. The answer is 3/4. Okay, as long as you add the period on, you're going to get the same ratio to come out. All right, I wanted to add one more example to this because I just want you guys to see it, and it's pretty easy. I don't want you to get it wrong. All right, what if they said given the sine of angle theta is equal to negative 2/3. So they've given you the sine ratio for angle theta. And they're telling you that theta is an angle between pi and 3 pi over 2. Well, what quadrant does that put him in? That's got to put him in quadrant 3. He's between 180 and 270 degrees. All right, they want you to find the 5 other trigonometric functions. Well, guys, you can use your whole